Look at this shark wearing some shoes. Who did that to him? Okay, so today is a follow-up on our previous video, which was setting up your slicer software for 3D printing. Okay, and today we are going to do some actual printing using that software. Okay, so I think there are two basic ways to get a model for 3D printing. One is either the most basic, okay, is to design it by yourself. Open any software you like to use, like there is SolidWorks, Fusion, all those apps you can draw in. That's anyone is cool, anyone will work. But the other easiest way is to download free models of other people. In fact, there's a huge database of free models. People just design and they just upload. Okay, so you go there, choose anyone you're interested in, and download. Easy as that. And so today, to test our method out, to test our software we have finished setting up in the previous video, we are going to go by the easier way, stress-free, just fun style. Okay, and just download something and 3D print. Let's go with it. So I'm going to open my favorite browser. I use Chrome. Okay, so now you're going to type in Thingiverse. There are several free websites also, but Thingiverse is kind of popular, it's kind of big, it's a huge database. So let's just use that. Later on we will explore other stuff. Okay, so Thingiverse. I don't know how you're going to pronounce this, Thingiverse or Thingiverse. Anyone will work. Press enter. Okay, right there it is loaded. Just up front you can see a whole lot of designs. All of these are 3D printables. Okay, see this cute dog here, nice bulldog with some huge eyes. Look at this shark wearing some shoes. Who did that to him? A whole lot of stuff. Now, to narrow down the search for you and make the work much easier, you can come in and type something related. So for example, I will type in pig. I don't know, I just couldn't find anything. Pig, let's find a pig. Okay, pig is in. Oh damn, we have some very jacked up. What is it? Oh, it's kind of nice and messed up a bit. The only thing is that there are too many ads in this site, on this site, so you just have to be. This is a nice sleeping pig, a cute one here. Okay, and guess what? The cookie cutter. So you can 3D print cookie cutters if you're into bakeries or stuff like that, and then make some cool shapes using 3D printed parts. Alright, so that's it. Oh, look at this cool one, flexi articulated pig. This one is jacked up. There's a whole lot. Okay, so let me search for let's search for a car. Okay, this looks cool. This looks cool. And oh, my network is a bit slow. Right, so there are some cool models in here you can download and 3D print it. This is amazing, to be honest. Okay, so now you get a point. You can just type in something, and if there is a corresponding item related to the name you put there, then it's gonna pop out. You're gonna select it, go screen through it, and choose whichever one you want. Okay, today let's make it easier. Okay, very basic. Let's type in a box. Mainly the calibration box. Tell you why soon. Calibration box. So a calibration box is basically something you print with your 3D printer to check the dimensions of it. One thing a 3D printer should be able to produce is accurate parts. Okay, of course we know you're dealing with plastics, you're heating and they're cooling, and when things heat up and cool, they expand and contract at the same time. So there's going to be some tolerance issues here, but it should give you fairly good results. So I'll find this calibration box. You see there are a lot of boxes in here. You can choose whichever one you want. I want to go for I'm looking for a specific one. Okay, so this is the one I was looking for. Let's choose this first one. I'm going to use this one. I know of this, so let's just use this one. You can choose any box you want to design. It's up to you. Okay. Oh, there is this cool one. Should we let's select this one. Let's cool. Let's go with that one and use it for our test. All right, that's how it looks. So this is the model of it. This is actually in the format of STL. This looks cool. We can see other pictures. So this is the actual printed thing after it was done printing. Okay. So how to download this? Always you want to download the STL.stl. That's the format you can put in your slicing software. So this arrow right here, we are going to click it and download it. Now our calibration box is downloaded. Alright, now that we have it, let's open our software and then prepare it to print. The name is Preset Slicer. I have it right in the top corner there. I like this software. It's having some really unique visuals. So open your slicer. We have installed this in the previous video, part 1. If you haven't watched that and you really need to, please check it out. Okay, this is the interface. Okay, this is the interface. Now what we are going to do is this platform here is where we prepare our things, our file. You see the visuals of it. So what we're going to do is go and bring in the file we downloaded. This icon here, this icon here means to bring in something. So you just click it, add, and then this is the file we downloaded, CaliCube1. Select it and then open. And now guess what? It's brought in here. Okay, it's a nice rounded box right there. Okay, and so now we are going to check a few things and then we 3D print them. Now we cannot explain all the features in this app one time, so what we are going to do is go along with it. Whatever we need at the moment, we talk about it, and later on we keep on exploring and then explaining a lot of things around this software. So basically the basic ones you need to print this box sitting right here is this. Right away I'm going to press slice. The slice is at the bottom here. Click it and see what happens. Now this is what you see. Okay, wait. So this is how it looks like. This is a sliced object. This is what your 3D printer can print now. And look at it. If you slide this bar down and up, can you see what is happening here? So this is how the box we downloaded is interpreted for your 3D printer to print. It's a bunch of layers. So you have the first layer, the second, third, fourth, fifth, all the way up. Now let's check a few things. If you go to your print settings, I want you to check this thing. The first thing is the layers and perimeters. You see this layer height 0.3. What does this actually mean? So you see, if you get back to our file, for each layer, the layer height means that the gap we leave between each layer, right? You know, when your printer is printing, it prints the first layer, it has to move up to create that gap for the next layer to come, and then move up again, create another gap for the next layer. So what is the distance? That is what is called the layer height. The rule is your layer height, this value cannot be bigger than the size of your nozzle, right? So what is the best explanation we can give here? Your nozzle, where the hot plastic comes out of, the hole size is 0.4 millimeters, right? So that means is theoretically the plastic that is pushed out of there is having the same size as 0.4. Think of it that way. Okay, and so if you set your layer height to be bigger than 0.4, what that means is that, okay, that means the next layer you're about to deposit is not going to be touching the previous layer, right? So to make sure you don't get into this problem, this value should be smaller than your layer height. Should be smaller than the size of your nozzle. That way we guarantee that any layer that the printer puts is going to be in contact with the previous layer, and so it's going to have the strength it needs to be a solid part. If the gap is too big, then there's going to be holes or gaps in between each layer. So that's what this thing is about. The standard one is 0.3. Of course, you can change this anywhere from 0.1 to the highest number, which is 0.4, the exact size of your nozzle. So now with this 0.3, each layer is 0.3 higher. Okay, now after we slice this, if we check the legend, see the time. So this box is going to take 16 minutes to print. 16 minutes. Let's see how your layer height affects the time it takes. Let's go in and make our layer height 0.1. So that means we move up just a little, 0.1 millimeter. Now 1 millimeter is even tiny. It's so tiny it's hard to see, right? Now think of 0.1. That is 1 millimeter divided by 10. So we are going up very tiny amount to put the next layer. And let's slice that and see how long it will take. Slice it. Good. And we see the time. The time is now 41 minutes. So the time has increased significantly, right? Why do we have to do this? Sometimes you need to get the best quality. If you want to get the best quality, you have to go smaller, right? If you want to print faster, you don't really care about it, then you can set your layer height at a very high number. But 0.1 is ridiculously too small. Yes, it's going to work, but it's going to take too much time. So 0.3 works most. All right, so set it at this, and when we slice it, the time is much smaller, 16 minutes. So it moved from 16 minutes, from 41 minutes or something like that, right, to 16 minutes. That's a big time reduction. Okay, so it's up to you. Balance this thing, whichever value you want, you put it in there, test it and see which one looks better for you, then you can place it there. Okay, the next thing we are going to talk about is the infill. Okay, no, on the same layers and perimeters, there is something called perimeters. See here, 3. What's the meaning of this? Let's go back here. So if you look at our model somewhere here, let's take right there. These are the walls, right? You see this thing here, those 3 lines here, these are the walls, and they are called the perimeters. So sometimes you want the thing you're making to be very strong. Okay, so you can increase the number of lines it puts, the number of walls. The more the walls, the stronger it is. So if we set perimeters to, let's move it from 3 to maybe how many? 16, 18. That's too big, but let's see what will happen. And let's slice this. Okay, so now you can see we have a very thicker wall, right? And if you have to count these walls, they're exactly 18. 1, 2, 3, 4, 5, blah, blah, blah. 18 lines. So now you have an object that is very thick, very thick. But guess what happened to the time? The time increased to 39 minutes. It was 16 minutes before, but now it increased to 39 minutes, because making all of these walls will take a bit of time, right? Although you're going to get a very strong part, but it's not very necessary. We will take it back to 3. 3 walls are okay. Good. So that is it. Now another way to make your print very strong, another way to make it strong without increasing the walls, is this factor called here infill. You see this here, infill. Now this is set to 5%. Guess what will happen if I set this to 90%? 90%, and let's slice it. So you see on the inside of our box, it is being filled with some shapes. Okay, so this is to help make your box more rigid. Now depending on the percentage you choose, if you choose 0%, let's see what 0 looks like. 0% means there's almost nothing, there is nothing in your box, right? It's empty. So you just have a very hollow box. That's what 0 means. So you can adjust this depending on how you want your part to feel like, the rigidity of it. You can choose any one you like. Now it's incremented by 5, but you can choose anything in between, like 6%, or 7, anything in between these increments. So that's what infill means. Okay, that's what it means. The next thing now is set at 6%, so we have a bit of things infill put inside our box to make sure it is stronger. The next thing we are going to look at is the speed at which we are going to print them. So you see the perimeters, we talked about this, is the walls, okay, the walls of it. We set it at 70. Now these values are what we have played around testing Ubuntu with, okay, and we think these values are very good. So if you don't know where to start off with, just put in these values just as they are, and over time you get to adjust it by yourself and see how it feels like for you. Okay, so these perimeters is set at 70 millimeters per second, so that's how fast we print the walls. Okay, and there is something called small perimeters. Sometimes you want to print it, for example, you see on this box there are these small round circles here, 1, 2, 3, and 4. They are so small that if you print it so fast, it will not turn out good, right? So this factor here checks for those things. If there's any smaller part on your thing, it's printed at a very smaller speed to make sure you get the best quality. And we have external perimeters. Now, what's the difference between perimeters and external perimeters? Your walls are all perimeters. Okay, in this case, our walls are 3. 1, 2, 3. But you see, the last one is a different color from the inside 2. That is, in 3D printing, the slower you print, the better it looks. So because the wall, the outside one, is what is going to be visible to people, you want to print that one a little bit slower so that it looks the best. But anything inside of it, we don't really care, because for example, if you take this infill, the thing that is inside of our box here, no one is going to see it because it's going to be closed at the top, so the inside is not relevant. So for those kind of things, you want to print them fast. We don't care, we just don't care how they look. But for the outside, you want to make sure it looks good. So that's why there is this factor called external perimeters, and the speed is quite smaller than the perimeters itself, just to ensure you have very good looking parts. Okay, and this is the info. We talked about that. You see the speed is 80. We print it fast because they are useless, right? They help it, but they are not very important. We don't need to see them. We don't need to see them look good. That's the point. Okay, so we have other speeds here. For now, these are the very basic ones we need that we are going to use. So later on, we will, as we do more designs, we will explain more of these things. But for now, guess this is how easy it is to download something, prepare it, and you're ready to print. Now on the left here, if you click legend, if you slide this bar, then there are 2 bars, one on the right here and one on the bottom here. See this bar, right? So this gives you kind of a simulation of how your printer is going to print each layer. You see that? So on the left, you will see these codes, these lines here. These are the codes that represent that specific layer the printer is printing. So if you look at it, if you take this line for example, you see some letters and numbers mixed up in there. We have X and some number, Y a certain number, E a certain number. So let's see what these things mean. You know, your printer is having X axis, Y axis, and Z axis, and also there is a extruder. Don't forget, the extruder is what pulls the plastic. Okay, now any number attached to X means that how much x-axis should move at a point in time. Okay, on this particular layer, at this point where the nozzle is, how much it should move, right? And there is y. This number tells the y-axis how much it should also move. And there is e. The number attached to e is for the plastic. It tells the printer how much plastic we need to push at that point. Okay, so these are the codes. This is actually the code your printer understands. So your printer is basically reading this code, these lines, and then making, as a result of that, it kind of produce a layer for you. So you see that? Good. There you go. Now you can see right here, somewhere here, there's a Z, and it's called layer change. So that is when your layer is finished. When one layer is finished, then the Z is going to update. So the Z is going to go up bigger, a little bit higher, right? And then the next layer will kick in, just like that. So from the ground up, you have something that is growing each time, and each layer is governed by the codes that tell the printer what to do each time. Guys, that is how easy it is. Now we are ready to print. How do we do that? So Ubuntu Tiny uses an SD card to print. So you're going to save your file, this file you have sliced, onto the SD card and then give it to your printer. Now right here there is export. Okay, so now we can export our file onto our storage. Okay, my storage is not showing. Maybe this thing is faulty. Okay, right there. Now once your SD card is detected, it shows up here, and on the far bottom corner right here you will see export to SD card or flash drive. So you can just click this and it will export it, save it directly to the SD card you inserted. So here you can change the name, or you can keep the name, whatever you want, and then save it. So after that, now you have your thing saved. You can eject it and you're ready to give it to your 3D printer to print it for you. Let's check how that goes. So now we are going to put back our SD card with our loaded file, just like that. Push on it, and now it shows up right away. Can you see the name of is the first one, CaliCube? Or you can select from the screen menu. So you go to print from media, click it, and now you see we have two files here, the CaliCube, the one which we saved, and the second one I put it there a long time ago. So we select the CaliCube, click it, and then put it on print, and then immediately your printer will start to prepare to start the job. There you go. So as usual, it's going to do the bed leveling first, which is mapping out the surface, touching about 9 points on the surface of the bed to make sure it is even.
Awesome.